Good morning, developers. If you are new to the channel, my name is Rob, and it is Algorithm Monday. And today we're going to look at Gnome sort, a sorting algorithm. And if you'd like to see the playlist for all the sorting algorithms that I have done, I'll drop that in the playlist as well as Algorithm Monday. Gnome sort is a sorting algorithm. Its job is to take a list, run through it, and make sure that it is in order when we get finished. Whether it started that way or if it was horribly out of order. It is not a good algorithm in terms of efficiency. It has an n squared. That is not good. You'd use heap sort, merge sort, quick sort, something like that if you needed to implement one. Usually the sorting algorithm that your programming language has implemented, that method is usually going to be the fastest. But this is awesome because it is so simple. It is so easy to understand, and it helps us understand how computers and how programming languages work. If you don't know what a gnome is, I will throw one up on the screen here. This happy guy graces my garden every day, and he is interested in gnome sort in getting some flower pots in order. At least this is the way it was always described to me. We've got our list, and think of each of these as a flower pot. The bigger the number is, the taller or the bigger the pot. The gnome is interested in only two things: the pot that is in front of him and the one that is behind it. If they are out of order, then he switches them and he goes back to make sure that he didn't miss one. If they are in the correct order, then he moves forward. So he only cares about two pots, the one right in front of him and the one behind it, and that is it. He moves around, but he never cares about any of the pots. So he starts here at the very beginning. If he's at the beginning, he doesn't have anything to compare it to, so he moves forward. Okay? Is 1 bigger than 6? It's not. That means it's not in the right place, so these two have to swap places, which means we end up with 1, 6, 9, 2, and 7. Anytime he switches pots, he has to go back one space to make sure that it didn't skip. Well, he's back at the beginning, which means he's going to turn around and immediately move back up to this spot. Okay? He compares these two again. Nothing to do, so he moves forward again. He's now here. He compares these two. Nothing to do, so he moves forward again. He's underneath the 2 now. 2 and 9 are in the wrong place. That means they have to be swapped, and it means he has to go backwards. So we end up with 1, 6, 2, 9, and 7, and he is he's in front of the 2. He compares the 2 and the 6. Those have to be swapped, which means he also has to move backwards again. So he ends up with 1, 2, 6, 9, and 7. He is now right there. Compares 2 and 1. They're in the right place. He moves forward. He moves forward again, moves forward one more time. 7 and 9 are in the wrong place, so swap those two, and he has to go back. For our last one here, we've got 1, 2, 6, 7, and 9. He's under this one. Is it in the right place? It is. He moves forward. Is it in the right place? It is, and we are done. That is how gnome sort works. Look at the one you're in front of, compare it to the one behind. If you need to switch them, and move back. If you don't need to switch them, move forward. The code will be really simple. It's just going to be while I is less than the length of our array. If that's true, that means there are pots to check against. If we are on, so it'll be if I equals 0, or if array I is greater than or equal to array I minus 1. So remember, our gnome only cares about the one we're on and the one before it, and that's it. If that's true, then we can move forward with an I plus equals 1 or I plus plus whatever. If it's not true, else, then we are going to swap, and we need to do an I minus equals 1 because he needs to go back. Okay, let's go code it out. Over to VS Code, I have gnomesort.py opened up with a couple of its friends here, its n squared friends. Got a little bit of starter code. Line 1, we import the random module when we're finished, and it won't take very long. So if you don't know Python, you should be able to follow because it's fairly simple. We're going to generate a really big random array. We do that for all 4 of these. It's not going to be totally fair because one of them might get lucky and have a mostly sorted list, but it should be pretty close. We grab the start time and the end time so we can print off the difference. That happens in all 4. And then we've got our array from the board on line 5. we start off with I at 0. That is our index, and that is the flower pot that our gnome is on. While I is less than the length of the array, the gnome has more pots to check. When this is no longer true, then we are out of pots, we are at the last one, and we can be finished. Okay, we're going to check to see if I equals 0 or if array I is greater than or equal to array I minus 1. So we're doing two things here. Are we on the first pot? If so, then I plus equals 1. Move forward because we don't have anything to compare behind it. Or is the one we're on bigger than the one before? If so, move forward. Okay, that's really simple and really straightforward. Otherwise, we are not on the first one and this pot is smaller than the one before it. We need to swap them. So we'll store the value of array I in temp. We will overwrite what's at array I with array I minus 1. We'll overwrite array I minus 1 with temp. So you can do it a little bit fancier, but these three lines are very straightforward. We just swap the values and then we do an I minus equals 1 because gnome must go back one pot. And that is it. That is the implementation of gnome sort. If we come over and run our code, we get a nice sorted list. If I just hit a bunch of keys here and just get some random values in there, run it again, we are in good shape. Now, this is going to be ugly. Let me get rid of those numbers. We're going to bring in line 6 here. And this is not, actually to be fair, I'm going to get rid of line 18 so that we don't have to print off that whole thing. And it took gnome sort 6.7 seconds. So that's not good. We run insertion sort, took a little over 1 second. And bubble sort takes about 4.5. So lastly, we run selection sort. And it was just barely faster here than insertion sort. Again, not a great algorithm because our poor gnome is moving pots like crazy, but so simple, so easy to understand. Thanks for watching. I will see you next time.